You are welcome in the tutorial class of optional math class 9. Topic is relation and function, and it is the second class of the topic. Question is here, concept of function. Yes, of course. Today I am coming here to teach you about function. That means concept of function. Student, you know very well function should be defined on the basis of relations, and relations defined on the basis of Cartesian product. So in the previous class you have learned about the relation that was started from Cartesian product, and today to define the function or to make the clear concept of function, I am going to start from relations. See, I am going to draw some arrow diagrams. Arrow diagrams are here. This is set A, set B. One relation I am going to set up here, denoted by R1. Another arrow diagram, set P, set Q, and its name is R2. Third one, arrow diagram. There is not sufficient place. Third one, arrow diagram. It is denoted by R3, and fourth one, arrow diagram. It is denoted by R4. PQ, XY, M, N. I am going to set up the relations in the arrow diagrams. See here, 1, 1, 2, 4. This is a relation. Y is square of x. Similarly here, 1, 0, minus 1, 1, 0, 4. This is also relation. This is y equals to x square. Third one, y equals to x cube. This is also y equals to x square. Here I have represented 4 relations, R1, R2, R3 and R4. Here all of them are relation, and here when we go through the relations, then let's see what we are getting here. All the elements of first set is mapping with the elements of the second sets. Here also all three are mapping with the one element of the second set. 1 is mapping with 1 and minus 1 is also mapping with one element. 0 is mapping with one element, but it has no any pre-image. Here third one, 1 is mapping with 1, 2 is mapping with 8, and 9 has no any pre-image. Here this is minus 1 is mapping with 1, 0 is mapping with 0, and 1 is mapping with 1, but it has no any image. But all are relations. In the relations, in the above relation, when we see the relation, then some has problem to be a function. What are the problem for them? Here see, 2 has no any mapping, and this 1, if we write here, this is mapping with here, then this 1 is mapping with two different elements of this minus 1. Here in this relation, 1 is mapping with two different elements of the second set. Here in this relation, 2 is not mapping with any elements of the second set. So strongly we can write here R1, R2, R3 and R4 are the relations. But in the relation, above relations, some of the above relations, see here R3, but in the above relation, R3 is a relation, but when we see the mapping diagram, arrow diagram, then 1 has two different elements, means 1 is mapping with two different elements. And when we see R4, see here R4 also, here 2 is here, which has no any image in the second set. So R3 and R4 are not such type of relation where every element of first set is mapping with the unique element of the second set. Now I am going to define function. Those relations in which every element of every element or member of first set maps with unique, that means single element of second set are known as are known as function are known as function. In the above arrow diagram, some are function and some are not function. Example you have seen. This is representing a function, this is also representing a function, but this is not a function because one is mapping with two different elements, and this is also not a function because 2 is not mapping with any element of the second set. But in the definition of function, every element of first set should map with the unique element of the second set. So it has no any mapping, it is not a function. It is also not representing a function. So these two are function, but these two are not representing the function. Student, see here, after defining it, I am going to show two examples for the functions. The examples are, see here, I am going to show through the arrow diagram. Set A, set B, function denoted by f. Elements are 1, 2, 3, 1, 4, 9, 16. Another mapping diagram. Here set P, set Q, and function is denoted by G. Here elements we are going to take 1, 0, -1, and similarly 1, 0, 2. Let's start the maintaining of function. Then 1 is mapping with 1, 2 is mapping with 4, 3 is mapping with 9. This is a function, as you have learned in the definition of function. See here, this is 1 is mapping with this, and -1 is also mapping with this, but 0 is mapping with this. This is also a function, as you have learned the definition of the function. Student, after knowing the definition of function, you have to know two words also here. See here, domain, and here codomain, and subset of codomain is range. Range is the subset of codomain. Here, if we write here from here for domain of f, then domain of f equals to, we write here 1, 2, 3, and similarly codomain of f, codomain of f, then we write here 1, 4, 9, 16. This is the codomain of f. Codomain of f. Similarly, if we want to write range of f, then we write here 1, 4, 9. This is the domain of f, and this is the codomain of f, and this is the range of f. So similarly, we can write here domain of G, codomain of G and range of G. We can write here. See here. What are they? 1, 0, minus 1. 1, 0, 2. And here 1, 0. What we are looking here, domain is the first set in the function. Codomain is the all the elements of the second set. And what is the range? Only the mapped elements of the second set are the range. Here you learned about the domain, codomain and range also. Sometimes what happens, see the third also, this is third and denoted by H. We write here X, Y. We can write here, this is 1, 2, here 1, 4 and here minus 1. See here, mapping, this is mapping with this. In H, domain of H equals to 1, 2, minus 1. Codomain of H equals to 1, 4 and range of H equals to 1, 4. See here, in this what we are getting, codomain and range both are same, both are equal. Yes, sometimes it happens. Then if sometime this codomain and range happen, then what will happen? I am going to teach you in the case of onto function and into function. See here, type of functions. I am going to tell you about type of functions. Here is onto function. And here is into function. From here only I want to make you understand about the onto function. A function in which codomain and range are equal is known as onto function. Student, to be onto function, domain, codomain and range should be same. You are getting here in the third example. See here, third example, codomain is 1, 4, range is also 1, 4. So H number is the example of onto function. Let's see into function. It is also a function in which codomain is not equals to range of the function, is known as into function. In the above example, see here, first one is also into function and second one is also into function. This is 1 to 1 into function, this is many to 1 into function, but this is many to 1 onto function. We can represent one example of one-to-one onto function also. Student, you have learned the concept of function. Finally, I want to tell you all the functions are relation, but all the relations are not the function. Hoping you have learned many more things here in the class. If you have confusion, once go through again the video, you will understand very clearly. Finally, I would like to request you, don't forget to subscribe it. Don't forget to share with your friends. Don't forget to inform to your friends, and request your friends also to share it and subscribe it. Thanks for watching the video.